Scientific Phenomena, Module A, Part 3. The learning targets for this portion will be: I can explain the role of phenomena in the new Iowa Core Science Standards. I can distinguish between anchor and lesson phenomena. And lastly, I can identify key components of instructionally productive phenomena. What is phenomena? Before watching the video and reading the upcoming article, take a couple minutes to go to your science module artifact document and record what comes to mind when you hear the word phenomena. This will serve as a line of learning. We are going to start learning around phenomena by watching a short video titled Using Phenomena in NGSS Designed Instruction.
Phenomena are really key in NGSS. What we really are after with NGSS is helping kids connect what they're learning about the science to what goes on in the world, not just learning in the abstract. And by phenomena, we mean, what is it that's happening in the world that we need our science to explain? Or what is the problem in the world, and what aspects of the problem in the world are we trying to engineer or change around to solve some problem? So rather than just learning about science or learning to do some engineering, we're trying to figure out how to connect that to something important in the world. We call the thing that's happening that we want to understand or change the phenomena. Well, phenomena are very common in science classrooms because we always like to take ideas and see how they play out in the real world. But I think one of the biggest shifts in NGSS is really using phenomena in a different way, using phenomena as the starting point, using phenomena to raise questions so that we build the science knowledge or work on engineering problems in the context of trying to understand or solve a problem. So rather than teaching the idea first and then giving the phenomena as an exemplar, we often start with the phenomena, because that is the thing that we need to explain. That is the thing that motivates the knowledge that we need to figure out. And that is the thing in the world that directs the knowledge building that we need to do. So rather than learn the science and apply it to the phenomena, we often want to start with the phenomena that we're trying to understand and build the science knowledge in order to make progress in modeling or explaining that phenomena. Maybe continuing to return to the phenomena as we make more and more progress and build more sophisticated versions of that understanding. So they're not something we bring in after the fact. They're something that we thread through and become the context in which we're applying the science knowledge as we're building it. The whole idea of NGSS is to make learning more meaningful for kids by engaging them not just in sort of the bare facts, but what are the big ideas behind those facts, and not just in sort of learning about facts or ideas that other people have figured out, but by engaging in the process of figuring them out themselves, and with help, of course, from teachers. But that process of figuring out makes what we're building in the science classroom much more meaningful for kids.
Now that you've watched the video, I want you to read the article, Using Phenomena in NGSS Design Lessons and Units, located under the resources of this assignment. As you read the article, please consider the following questions. What did you believe about phenomena prior to reading the article? What do you believe now? Why do the framework in NGSS focus on phenomena? And what makes a phenomena worth using in instruction? Now we're going to go back to your Science Module Artifact document, where we will add to our line of learning by reflecting through a 3-2-1 formatted quick write. On the artifact document, there is a place for you to record 3 essential ideas regarding phenomena or phenomenon-driven instruction, 2 examples of phenomena you might use in an upcoming unit, and 1 question you have regarding how you would use phenomena in the classroom. We are now going to revisit what is a phenomena. Phenomena are repeatable events or processes, things that happen, that are observable by the senses or detectable by instruments. As we move toward implementing the new science standards, we want to involve more systems thinking and modeling to explain phenomena and to give context for the ideas to be learned, moving our practice from learning about science topics to figuring out what is going on. Some examples of phenomena by science domain would be, for the life science, the evolution of different shapes of finches' beaks, or the number of bees decreasing. In physical science, some examples would be the motion of a pendulum or the changing temperature of a cup of coffee left on a countertop. And lastly, in earth science, some examples might be an earthquake or lunar eclipses. Phenomena does not have to be phenomenal. With the shift to NGSS, our minds can also shift and begin to see phenomena in many places. This aligns with our natural tendencies as humans to be curious about the world around us. How does phenomena align with the new Iowa Core Science Standards? The standards were designed as a way for students to be engaged in using the 3 dimensions to explain phenomena and/or design solutions, because this is how science works. The Iowa Core Science Standards were also written to support students in making sense of phenomena. The purpose of having students engage in science and engineering practices around real-world phenomena is to provide a context for students to construct their own understanding, use the science and engineering practices, disciplinary core ideas, and cross-cutting concepts. The phenomena or design problems introduced have to be carefully chosen to provide a context in which students become engaged and in which the science ideas they are learning are useful because they can help explain what is occurring. There are 2 types of phenomena, anchoring phenomena and lesson level phenomena. An anchoring phenomenon will require students to engage in multiple investigations in order to be able to explain the science behind it. It is like a finished puzzle, the big picture. Lesson level phenomena help students figure out smaller pieces of this larger phenomena, like the various pieces of a puzzle fit together to form the larger picture. For example, in a unit centered around the anchoring phenomena of generating electricity or energy conversion, a portion of the unit involves students engaging with lesson level phenomena on electricity produced via wind turbines. The following article, Qualities of a Good Anchor Phenomena, is located in the resource section of this assignment and highlights some key points to consider when looking for good anchor phenomena for a sequence of science lessons. When thinking about phenomena, you really want to dive into the standards and make sure you understand what is being asked of the students. What do the students need to know and be able to do? Remember, a resource on the Next Generation Science Standards site that will help you with this would be the evidence statements. Once you know what the standard is saying, you can look for phenomena to engage your students and help them construct understanding around the standard from a variety of places. You can find phenomena in the natural world, out-of-school experiences, and from the media, news, and websites. Now I'd like you to take some time to explore some of the phenomena sites located on the assignments for this page. Locate a phenomena that you could anchor an upcoming unit to and answer the questions about the phenomena in your science module artifact document. The phenomena should get kids engaged and curious. They will want to create why, when, what, and or how questions around the phenomena you have chosen. You just explored a couple different phenomena sites and identified a phenomena that would relate to the content you'll be covering in an upcoming unit. This phenomena would be your anchor phenomena, and that is where we must start when designing science units. Now we will need to create a driving question. Your driving question is a question created from the phenomena that students will be able to answer by the end of a unit. For example, my phenomena is a segment from a documentary about vanishing bees. My driving question I would pose to students would be, can we save the bees? Question boards are a way of housing and organizing students' questions. After being introduced to the anchor phenomena, students will create I wonder questions based on their observations of the phenomena. The I wonder questions will then be collected physically, for example on sticky notes, or digitally in a program called Padlet. Students and teachers are then able to organize the questions into common themes, and teachers can use those questions as their lesson level phenomena questions. When designing the question board, the order is created in a way where insight and learning experiences build to our understanding of the anchor phenomena, students and teacher created. The order of understanding is necessary to make sense of the anchor phenomena. And students and teachers will work together to group the questions by categories. For example, back to my bees, I could organize by survival, bee parts, solutions, the environment, and so on. We are now going to watch a short video about question boards in the classroom.
So the driving question board is a key part of our units. Sort of is this space where we keep track of our learning as the unit progresses, and it's a space where we motivate what it is we want to figure out. And there's a question that guides the content and the practices of the unit, but under that we hang all the kids' questions that can be linked in. So in a particular unit, like the one we're studying right now on biology, our driving question is, why do organisms look the way they do? This is going to motivate two big areas to investigate: things that we inherit and things that are environmentally influenced. Kids bring in lots of cases of their own experiences to that question. Families they know, friends they know, things that they've thought about for the last 12, 14 years. And so that driving question board becomes a space where kids bring in their own data, and the class brings in data. And over time, we collect more and more data, drive more and more questions from our own experiences in the world, so that all those cases end up being things that we can answer by the end of the unit. We're not just learning to learn the science, we're learning to figure out what it is we really want to know. So for example, up here we have a series of cards the kids have posted. One kid says, our family has family friends, and in that family, the mom has brown eyes and the dad has blue eyes. Two of their kids have brown eyes and one kid has blue eyes. Why is this? That kind of case is similar to a lot of other kids' cases, but each kid has their own unique story that they want to be able to answer. And by sharing those out and having them be a part of the unit, kids realize we have a shared mission in science. That is, if we can figure out the answer to my question, my answer can help inform the answer to your question.
Now that we have covered anchor and lesson phenomena and question boards, our future learning together will be storylines. When we meet on site, we will dive deeper into storylines. We will work to put our new learning around the 3 dimensions, anchor and lesson phenomena, driving questions and question boards together to design a storyline unit.